Welcome and thank you for joining. Let's take a look at this question. We have a circuit, and in this circuit we have two light bulbs with resistance R1 and R2. They're equal, each 80 ohms. They're in parallel, and these two light bulbs that are in parallel will be in series with resistance R3. The total potential difference, delta VT, is 120 volts. So we have to find the resistance of R3 so that the light bulbs will have a potential difference of 50 volts across them. So in order to find the resistance in R3, we need to know what current and what potential difference is there for R3. Now we need the current in R3, we need the potential difference in R3. Now remember that since R3 will be in series with R12, then the current in R3 will be the same as the current in R12. So we need to find that out first. Now, since these two are in parallel, then we're going to have to find the total resistance of R1 R2 using the formula 1 over R12 is equal to 1 over R1 plus 1 over R2. So that will make it 1 over 80 plus 1 over 80. And that will make 2 over 80, which in simplified form is 140. And we have 1 over R12 equal to 1 over 40, which will make R12 equal to 40 ohms. Now, if you wish, you can also simplify now your circuit because it does have still a potential difference of 120 volts. We have the R3 in here, which we don't know. And we have R12 right here. I'm going to make a bulb in here. So R12, which is 40 ohms. Now we know that the potential difference for parallel, in parallel, would be the same in both of them, so 50 volts. So we're going to say that if the potential difference is 50 volts, then it means that the current in R12, the total current, right? So, which we're going to call I12, would be equal to potential difference over the total resistance R12. Now we know that potential difference is asked to be 50 and divided by the total resistance, which is 40. That will give a current in 12 as 1.25 amps. Now we know that 1.25 amps will be the current here, or also the current in here, because they are in series, and in series the current is the same. So we're going to say that R3 is equal to 1.25 amps. Now we know we have to find the resistance R3, so we're not there yet. We need to find the potential difference in V3. Now potential difference in V3, remember R3 is in series with R12, which means that the potential difference would be equal to the sum of the voltages in each of them, so in R3 and in R12. So we're going to say that V3 would be equal to delta VT minus the voltage in 1,2. Or you can also look at it as delta VT, since it is in series, is V3 plus V12. It's the same thing, okay? So I'm going to actually just keep it in this format just to show the work and the thinking process. Now, V3 then would be equal to 120 minus 50, and that will make 70 volts. So now that we have V3 and I3, we can determine the resistance that is necessary to provide a voltage of 50 in each of them. So R3 would be equal to V3 divided by I3, and that will be 70 divided by 1.25. And if you use a calculator there, 70 divided by 1.25 is 50 something, 56. So that's 56 ohms. So thank you for learning with me. I hope this made sense, and bye for now.